Okay, welcome to video 10.4. Today we're going to talk some more about solving quadratics by using completing the square. So we've already introduced this idea yesterday, but I just want you to think of why is this x squared plus 8x plus 16 an example of a perfect square trinomial, and our hint is to factor it. Over here I've written my x box, and I need to find the two numbers that have a product of 16 and a sum of 8, and those would be 4 and 4. So if I were to factor this, I would split my 8x to be 4x and 4x plus the 16, and then you can go ahead and do factor by grouping to group the first two and the second two, and then we look for a GCF in the first two, which would be x, and a GCF in the second two, which would be 4. So we get x times the x plus 4, and then a 4 comes out left with x plus 4. X plus 4 is common in both, so I can write that first, and then the leftovers go in parentheses, so I would have the x plus 4. Well, if you notice, that's the same thing written twice. So I can really rewrite this as the x plus 4 squared. That's equivalent to x plus 4 times x plus 4. So that's why these trinomials are called perfect square trinomials. So we've already introduced the idea of how to solve quadratic equations by completing the square. Today I'm going to take you through steps that can be used to do that same process. So the first thing is to rearrange the equation by getting the terms on the left-hand side and then group the terms with the variables in parentheses. And remember, we do that because those are the ones that I can try to manipulate and change to make look like a square. So I've grouped them together and everything is on the left-hand side. Then it says check the a value. In parentheses, if a is greater than 1, we need to factor out the number only, so not the variable. I just know that whatever this is, the square here, so like in this case it's 2x squared minus 12x, well I have two squares that are x on each side. So I don't want to complete the square twice. I just want to do it once and then know that it happened 2 times, so the 2 is out front. So I'm going to divide out the 2 on. And when I do that, the 2 comes out front and I'm left with the x squared minus 6x, and I've already done the filler space line in the parentheses, so remember we're adding something to our picture to complete the square, but if we add something we also must take it away. And our note here is that you have to remember to do that and keep the expression equivalent. Then we complete the square. So these are actually the steps that we went over yesterday. The B number, the one with the x. So here I have 6 groups of x. Well, to keep it looking like a square, I have to divide it on half, so that half go on each side. So we take half of it. Square it, because remember we filled in the bottom, the missing pieces, by multiplying whatever was on each side. So in this case it'd be negative 3 times negative 3. So we would add 9. And then since we added something to our picture, we also must take it away. But we actually have 2 of these, 2 x squareds with the 12 x's all together. So this happens twice. So I'm not actually adding 9, I'm actually adding 2 groups of 9, which would be 18. So I have to subtract 18 here. Then the rest of it is what we've done to complete the square. So manipulate the expression in parentheses to write it as a binomial squared. So we did that when we figured out, okay, well, what is the value of the side of each square? So you can factor, but the shortcut is what we already did yesterday, so we don't have to factor every time. If I have 6 groups of x all together, and I put 3 on each side, my new side of the square is x minus 3. So we can rewrite this as 2 and then the group of the x minus 3 squared, and combine like terms to be the minus 4 equals 0. Then we solve like we always have. So I can add 4 to both sides to get the 2 times x minus 3 squared equals 4, then divide by 2 on both sides, and we get this x minus 3 squared equals 2. Then we have to take the square root of each, and when I do that I get x minus 3 equals plus or minus radical 2, and the last step is to add 3 to both sides. So we get our final answer of x equals 3 plus or minus radical 2, which we cannot simplify. There are no perfect squares that go into 2, so we're left with that answer. Okay, that's it for this video. We'll do some more practice tomorrow. Have a good night.